All right, students. So now we'll see practical or experiment based on Ohm's law. Okay. So you can see that I have made two circuits, or rather three circuits here. In one circuit, I've connected load, that is 3 LED. You can see here 3 LEDs connected in series. Okay. And negative is this side and positive is this side through a resistor I have given it. In another circuit, I have connected the 3 resistors in parallel. Okay. You can see 3 resistors I have connected in parallel. Other side of the breadboard, I have connected 3 resistors in series. These 3 resistors, you can see 1, 2, 3, R1, R2, R3. And the same R1, R2, R3 of same value, I have connected in parallel also. So we'll check according to Ohm's law. We'll just check both the circuits. Okay, right. So I will take this circuit first. So what I will do is I will just give connection to this and I will just put my meter to volts. So we are testing the voltage first. Okay, we are testing the voltage first. So I'll just connect these things and I will just give you a complete idea. Now it is working like. So according to Ohm's law, what is the formula? What should I get according to Ohm's law? I should get positive. I should get, this is the supply voltage. Okay, this is supply, like sorry. So this is supply voltage, that is approximately 5.74. Okay, so across the load, that is load number 1, load number 2, load number 3. So if I'm testing on load number 1, like after the first LED, it is coming approximately 1.89. Okay, 1.89. And if I test on the second load, that is 3.81. That is first load plus second load. If you add, you will get 5.69, right? So total voltage will be 5.69 by adding the values what we have got. Okay, right. Now what happens to the current? What happens to the current when what happens to the current when it is connected in series? It will be same. Please remember, it will be same. So I will just put this thing to current mode. I'll put it to current mode, 200 milliamps. You can see here. So I will check the current across this. Okay. So across this, the current is 5.4, 5.1. Okay. It will be same across this thing, all of the junctions, approximately same. Sorry, it is 5.1, approximately same. It will be same across this junction also, right? So according to Ohm's law, current will be same, right? That is I1 plus I2 plus I3, 3 junctions we have tested. It will be same. Okay. So this is a simple Ohm's law. You can do it. Take a breadboard, LED, and resistor. Connect a battery. Any battery will do. So this is about connection in series. Now what we will do, we'll take another one. This is it is connected in parallel. Okay. So I will just give connection to the parallel line. I will get this and I will just switch it on. Now in parallel, what will happen in parallel? Voltage will be same across V1, V2, and V3. That means V1, V2, V3. So let's check the voltage first, whether it will be same or not. Okay. So negative, positive, I'm just putting it here. V1, it is 1.90. V2, it is 1.90, approximately same. And V3 also, it will be same. Correct. So the voltage will be same. Okay. When it is connected in parallel. Right. Okay. What happens to the current? Let's see what happens to the current. So I will put this thing into this thing. I will just connect it to this area and I will see what happens to the current. It is 11.9. Here also, that is I2, it is 11.9. And I3 also, it is 11.9. It's very simple, right? Current is same. Okay. We can check this in this way also. I can remove this. I can put my negative on the negative of the lead and I can check here 12.1, 12.1, and 12.1. Okay. So the current is same. Here also we can check, right? 7.8, R2, 7.8, and 7.8. So it will be same like, okay, right? So this is about current and voltage according to Ohm's law. Now we'll check the series and parallel. How I have connected, you can just have a look. R1, R2, R3, R1, R2, R3. One is in series, right? And one is parallel. So for testing, we don't have to give the voltage to it. I will just put it to 2K mode range. That is resistance range. Now I'll just check one resistor first. I'll put it here and I will put it to the first resistor. How much it is coming? It is coming approximately 0.097 or approximately 800 ohms, right? Second resistor value is also same. Third resistor value will be same. When the R1, R2, and R3, the total resistance, how much it should be? The R1 plus R2 plus R3, it is 2.94. Okay. So please remember, the values, resistance value are added in when the resistor are connected in series. But what happens in parallel? Same values I have used it here. So what happens in the parallel? You can see here, in parallel I have connected. It is 0.031. Let's reduce the value in the meter. I will put it to 200 ohms. So let's see how much it is coming. It is coming to 32.8 or 33 ohms. Correct or not? So according to the formula, R total is equal to 1 by R1 plus 1 by R2, 1 by R3. That is, we have seen the 300 ohms, 100 ohms, 100 ohms. If you divide, it will be approximately 33 ohms only. So in series, the value gets added. In parallel, the value gets divided. It will reduce. Okay, that is the idea of giving you the formula for Ohm's law. Okay, that is the formula for Ohm's law.